there, cutie patootie math angel. Welcome back. Welcome back. Hello, hello. And a very warm welcome if you are new around here. This is Decaf-Math ASMR. And thank you for choosing to check out the channel and for coming along. So today we are going to be playing around with literal equations. Literal equations. And this was a requested topic, and I didn't know that there was actually a word for this kind of thing, this kind of process, this kind of exercise. Turns out the word literal means variable, or they can be used interchangeably, I think. So I kind of looked it up really quickly actually, and once I got the concept I kind of forgot to check the part of speech, so I don't know if it's just an adjective, so just a literal equation, or if you can actually use it as a noun and use it interchangeably with variables. So would you say that an equation has three literals, three variables, three literals? Sounds a little bit suspicious. Oops, I should have looked it up. But if you happen to know, please do comment down below. Otherwise, I will look it up at the end of this video and let you know. But either way, a literal equation is basically an equation that has more than one variable. So 2, 3, 4, 5, however many variables you want, as long as it's more than one. And to solve a literal equation just means, for a particular variable, just means to isolate that variable on one side and write it in terms of the other stuff. And that's it. So we're just rearranging stuff using a little bit of algebra, just doing a little bit of math. We are writing one in terms of the others. And so this can be used, as you could imagine, in pretty much anything that's like the basis of math, is just solving these unknown things, right? So anytime we're kind of rearranging stuff and trying to solve for a particular variable, that's this kind of thing. So today I just want to offer some tips, tricks. We're just going to relax, hang out, and kind of hopefully I can help you kind of break it down a little bit. As always though, our first and foremost goal is to just celebrate this moment here and right now. I'm really just enjoying the quiet, the peace, and just being grateful that I can be here with you and that you can be here with me. And that is, after all, that's why I'm here, right? Just the love that is all around. And of course then math happens to be our language for that here. And so I just hope that this can bless you however you need it at this time. So if you are trying to drift off to sleep, I hope that the soft speaking and the whispering are extra soothing for you, and that you can feel safe and comfortable enough to just drift off and let your worries from the day just fall away. If you happen to just want to relax instead but aren't quite ready for sleep, I hope that this is a nice little diversion or a fun little way to learn and review and chill out. So I do hope that you'll feel free to just zone in and out as you please. There's no pressure, comparison, or worries around here, okay? It doesn't matter whether or not you're learning this, or if you think you're really great at math, or you think you're terrible at math, or somewhere in between. It's all good. It's all good. Okay, so let's look at a first equation just so that we can break down what's going on. A equals c minus 3. So this is an equation because we have an equal sign, literally, and we have two variables, the letters a and c. Those are our placeholders for our unknown values, and again, in this case, we are not trying to solve for exact values for a and c. In fact, it's impossible to. If you have one equation and more than one variable, it is impossible to solve for exact values, because this just gives me a relationship says whatever C is, A is 3 less than that C, or C minus 3, right? So it's nothing about the exact value for A and C. So just because you might find a particular pairing here, like if C is 5, then A would be 5 minus 3, which is 2. That doesn't mean you found exact values, because, 2 and -1 is also a pairing, so that doesn't actually tell you anything. You would need at least another variable with these two, at least another equation with these two variables in order to have a chance at solving for them. So that's not our goal. Our goal is to remember, just isolate the variable we're solving for and just rearrange using algebra. So in this case, we are solving for C because we already have A written for us in terms of C. So we're going to solve for C in terms of A. So the first thing I would do is to find the variable that you're solving for. Just locate it in whatever it is that you're looking at. So sometimes it's straightforward like this. Sometimes you'll have a whole lot of stuff. And I also don't mean to imply that you can always directly and explicitly solve these kinds of formulas. So especially if you're in pre-calculus or doing more complicated functions, sometimes you cannot isolate them and solve explicitly. But if we're working with this kind of thing, in general, it's safe to assume that, hopefully it is something that you can do. So here I'm going to find my C. So right there, ta-da, I found it. And I'm going to try to start undoing things so that I can have C on one side and everything else on the other. If you happen to be struggling with this, let's say you're checking your answers or you're getting feedback maybe from a teacher that something's a little bit off, I would take the time to try to see if the issue is this concept, like the idea of actually isolating this thing, or if you just have a little gap in the algebra work, maybe you need to take time with taking things one step at a time, or rebuilding a little bit of that, how to solve, how to manipulate these kinds of equations, and it's okay to take time to do so. So see if you can break down where the issue is. Is it your order of operations? Is it that you're not dividing by an entire quantity, but you're just doing a little piece there? There's a lot of little ways that things can, just even little things can kind of trip you up. So I just kind of want to encourage you there, because sometimes we just think, oh, we can't do any of this. We're terrible at math. I hate math. I'm never going to learn math again until you're forced to do it again. But sometimes it's really just a little tiny thing. So I just hope to encourage you in that way, and that it's totally okay to take time to do this. So in this case, solving for C, I have a C right here, and it's good to keep in mind what is happening to it. So I have C, and I'm just going to subtract 3. So sometimes you'll have like multiplication, you'll have like, exponents, or maybe a square root, or if you're doing more complicated functions, you might have like a natural log or something like that. It doesn't matter, but just it might help to kind of read it out loud or in your mind. So here I just have C, and I'm going to take that C and I'm going to minus 3. That means that when I want to undo all of this to isolate it, I'm kind of going the opposite of the order of operations, and I just want to undo everything. If you have been around, you know that recently we did a little inverse video. We talked about inverse functions, and this is kind of you can kind of apply that here. So the idea is I have a C and I'm going to subtract 3. So if I want to isolate that C, I'm undoing the minus 3 by adding 3. I have a minus 3 here. I'm going to add 3 because minus 3 plus 3 gives me 0, and that goes away. It's the additive identity, so anything plus 0 is itself. So this plus 3 comes from the inverse of the subtraction. But if I do it on this side, I have to keep this equation balanced, so I also have to add 3 here. So essentially that goes away, and I get C equals A plus 3, or A plus 3 equals C. See that? And as you do more and more of this type of thing, eventually you don't even need to write +3 and +3 anymore. You can think of moving this -3 over here by switching this minus sign to a plus, and you can start doing them in your head. But for now, if you need to take this step one at a time, that's totally okay. So this equal sign here, we've done like one-step equations around here, but we can do more practice. But anything that you do to one side of the equation, you must also do on the other, because the equal sign literally says A is C minus 3. A is A and C minus 3 is C minus 3 and A is C minus 3, so they're all interchangeable because of this beautiful, beautiful equal sign. Chef's kiss. So this equal sign is very powerful. It's very simple, but it's very powerful. So if I add 3, then I must add 3 on the other side. So I have A plus 3 is C, or in other words, we have C is A plus 3. And that's it. That is our first literal equation. I can't stop saying now, literal equation. So we have solved for C in terms of the other variables, which is A in this case, and constants are okay. So C equals A plus 3. So this would be an example of a little algebra concept that if you're not familiar with, then of course solving for this kind of stuff is going to be really confusing. So just make sure that you take some time to review this a little bit, or you can just ignore me right now until you have to or decide to come back to this kind of thing. Okay, and now let's look at another one. Let's say we have Fahrenheit and Celsius. For anyone who is reviewing for the SAT or ACT, this might look familiar. I've seen this kind of practice all over the place, and this kind of question might most likely will show up for like an algebra thing. But here we have Fahrenheit and Celsius, or F and C. This is actually a formula for how to convert between Fahrenheit and Celsius. So if I give you a temperature in Celsius here, this says multiply that by 9/5 and then add 32, and whatever you get is that equivalent temperature in Fahrenheit. Now, in just this equation, without any context, you might be able to guess it because of the F and the C, but just the math, it's like any other equation with two variables in it, so we don't necessarily need an interpretation, but of course it's cool to have a little bit of context. But this is where we want to know the order of operations. So from this sentence, this mathematical statement, the multiplication comes first and then addition. This is why we must know our PEMDAS or BEDMAS or whatever variation of that you know. But here we know that this multiplication comes first and then addition. Therefore, if we want to solve for C here, so solve for C, let's locate our variable. There it is, I found it. So we want to isolate that. But now, do I get rid of this 9/5 thing? Do I get rid of this 32? Well, you can do whatever you want as long as it's mathematically equivalent. But I would say the easiest thing to do is to undo this plus first. So if you think in your mind, what is the order of operations that normally happens? I multiply by 9/5 and then I add 32. So when I undo all of this, I'm going to undo the plus by subtracting first. So I'm going to subtract 32 on both sides like we did before, and I get F minus 32 equals 9/5 C. Then I'm going to undo this 9/5 times C. When it's smushed together, it's multiply. So that means that I'm going to divide by 9/5, which is the same as multiplying by the reciprocal when you flip-flop the top and the bottom. Divide by 9/5 or multiply by 5/9. It's the same thing. And if I multiply it on both sides here, I have to multiply the entire f minus 32 by this 5/9. So this is an example of what I mean by the algebra part. Make sure that you're doing the entire f minus 32 quantity times the 5/9 there, you see? So that this 9/5 and this 5/9 go away. So I still have now I have my c isolated. But when I do this 5/9, I'm multiplying by the entire f minus 32. And you could just leave it like that. So we have c equals 5/9 times f minus 32. And that's it. So we have our c in terms of f. If you wish, you can distribute out this 5/9, but that's not necessary. In fact, this one is the most direct for what to do. If I'm giving you Fahrenheit, degrees in Fahrenheit, you subtract 32 because you do the parentheses first, and then you take that number and you multiply by 5/9. And if your calculator can't handle fractions, for instance, like 5/9 times that, then you can just do 5 times that number and then divide it by 9. And you get this equivalent degrees in Celsius. So solving for c, we get 5/9 times f minus 32. I hope that makes sense. So you're just locating it and then you're undoing things one at a time. And as you get more and more practice, you don't really need to write every single thing out, but to just try to keep in mind what your order of operations are. Okay? Okay, let's do another. That's it. You're doing great. Alright, let's look at v equals 1/3 pi r squared h. This is actually a volume formula, and this is the volume of a cone, and sometimes the formulas come from actual formulas in math, like in this case volume or whatever else, or other subjects like chemistry or physics or whatever. But sometimes you can just look at it like just a normal 1, 2, 3 variable equation and just do the math behind it. So just keep in mind what the context is, and I just wanted to make a point with that here because in this case, let's say this is the volume of a cone. So we have 3 variables. We have v, r, and h. Pi is a constant, so constant r, and then that r is squared, and then we have it times h, and it's all smushed together, so we're just multiplying everything. So for this one, let's solve for r, and let's also solve for h. So 2 questions in one, which I know it's not really fair. It's kind of like when you get a homework question and it's like doing questions 1, 2, and 3, but then each part has A, B, C, D, E, F, G, H, I. But we have 2 for 1 here, and I think that makes for some good practice anyway. So let's start with h because I think it's actually simpler. So let's locate our h. There you go, I found it. Let's look at what's happening to that h. I am multiplying by all this stuff, right? And that's why it's important to know what the subject is, because that's the thing you're zooming in on and focusing on. So here I have h times stuff, meaning if I want to isolate this h, I'm going to divide by this stuff. So that's exactly what I'm going to do. I have h equals, I'm just going to flip the order, v over all of this, 1/3 pi r squared. Or, left and right doesn't matter for an equal sign, because if a equals b and b equals a, again, seems like a simple statement, but it actually is a particular property of the equal sign, which is not always the case. But again, my love for the equal sign. But here we have h equals v over 1/3 pi r squared. Again, because we're doing this all in one step, it is important to put all of that as a quantity underneath, so divided by the whole thing. If you want to do this slightly differently, just one at a time, you could theoretically just multiply by 3 to get 3v instead. it's all up to you how you want to do that, as long as it's kind of equivalent to this in some way. But for now, just to make a point, I just wanted to divide by the whole thing. And then when I divide by 1/3, it's the same as multiplying by the reciprocal. That's when you divide by a fraction. It's the same as multiplying by flip-flopping the top and the bottom. So the reciprocal of 1/3 is 3/1, which is 3. So this actually ends up going up here. So you get 3v over pi r squared. So h is going to be 3v divided by pi r squared. That's it. So we have h in terms of the others. Okay, v and r. That's great. So we did the h1. Now how about the r? So I'm just going to rewrite this. If you're solving multiple in one question, I suggest that you always go back to the original question just to start over again, so that you don't get confused, which variable we're doing. You don't want to solve for h and then undo all of that again to go for r. Let's just start with the original question. So let's find our r. So there you go, I found it. So here what we're doing is we have that r, and we're going to square that, and then we're going to multiply all of that by this 1/3 pi h bit here. And for multiplication, the order doesn't matter, it's commutative. So this is 1/3 pi h times r squared. So now it kind of looks like we need to do two steps. We need to undo the multiplication. So let's start with that. So we'd have r squared equals, and then to undo the multiplication, we do the division again. So we have v divided by 1/3 pi h. And if you want, again, you could have multiplied by 3 instead. Doesn't matter. Here we have divided by 1/3. So we have 3v over pi h. Okay, so are we done? Almost, but not quite. So we have an r, which is true, but our goal is to solve for r directly in terms of the others. Well, I have r squared in terms of the others, but we need to actually have r equals. So to undo that squared, we need to take the square root on both sides. Because it's r squared, I need to do the plus or minus square root. So I actually have r equals plus or minus square root of 3v over pi h. Okay, so this is a classic example that I use, which is just always x squared equals 9. If I have x squared equals 9, then x is going to be positive 3 or negative 3. Because if I have negative 3 quantity squared, that's going to also be positive 9. So I need to do plus or minus the square root of 9 to get all the solutions. So in this case, I need to do plus or minus square root of 3v over pi h. Now, I had a point for this particular question in that if we're given context and we actually want to adapt it to the actual, situation, here I would have r is plus or minus this thing. But if r is the radius of a cone, depending on your setup, okay, if it's like set up on an xy Cartesian coordinate plane, then there could be a case made for the radius to be a negative number, I guess, if it indicates position in some way. It's kind of weird, right? You don't really think of a negative distance, negative length. So normally you would just go ahead and do r is positive square root of 3v over pi h, unless you had a good argument for something else. But distance is positive, right? So distance is a metric, I suppose. But anyway, that's my point, is depending on if you're solving this for depends on what question you're doing, but if you're solving this as just letters, like v, r, and h as letters, just algebraically, you need the plus or minus. If you're trying to interpret that for something, then adapt. And sometimes you need to get rid of certain intervals or certain solutions. So it's always good to check back, okay? But I hope that helps. So find your thing that you're solving for, locate isolate it and then look at what happens to it. So in this case for h, it's actually a linear thing because h isn't squared and it's nowhere else. It's just literally h. So it's stuff times h. So then when I want to isolate that, I just divide by all this stuff. If I want to solve for r, here I have r squared and I have times a bunch of stuff. So I want to undo that by dividing, and then I want to take the plus or minus square root. So it does change a little bit, right? Good. Let's work through one more for today, and then we will take it from here. Maybe we can do some more. I find this very satisfying too. So we can always do some more and write it out with some chalk or maybe on some crinkly paper. You can let me know. But yeah, I think this is just like a nice, fun, relaxing exercise regardless, I think. But let's say we have this. So I'm just trying to make up some questions that kind of cover the different types, or I mean, I can't cover everything, but you know, just different concepts that I think might come up. So let's see here. How about RT plus ST equals 5QP? We're going to solve this for T. Okay. So first thing, let's locate T. Okay, well, we have a T here and a T here. Interesting. Alright, so I found it or them. So how do we actually isolate this T now if it's in two places? Well, in this case, I have R times T plus S times T. So conveniently, we can actually factor, which is quite nice. The other side as is. In this case, actually, I could write it out more directly. It's easier to see it like this. R plus S times T. Because if I distribute this, I have R times T plus S times T, which is this. Because I see there's a common T in both of them. Now, because I'm still trying to isolate this T, I'm just going to divide by this thing. Move it over. So I have T equals 5QP over R plus S. And it's important to remember this order of operations here. So R plus S, because it's in parentheses now that we factored out a T, is a single quantity. The whole thing, R plus S, goes together. So when I divide, I have to divide by R plus S. And I don't need a parentheses if it's on the bottom denominator of a fraction, but the R plus S stick together. Okay, so unless you have your own little way to undo everything and kind of find something algebraically equivalent, make sure that you are clear with the order in which you're doing this, and if you're dividing an entire quantity, if you're dividing one piece at a time. Okay, so in this case, I think this would be the only way to get this T, really, because if you moved this ST term over here, then you'd have a T on both sides, and you still want to combine them together and then factor out this T. So again, it's not always possible to just explicitly express one in terms of these other ones, but presumably if you're working on this kind of question, that you can assume that you can. Okay, so I hope that this gets you started if you are learning this stuff. Hopefully just seeing some things worked out here helps. We can definitely take time and actually just jump right in next time to practice more, play around with it more. But today I just wanted to give some tips and tricks. So if you are asleep by now, I'm wishing you sweet, sweet mathy dreams. If you're getting ready for the rest of your day, I hope that it's a good one. Thanks for hanging out with me. I'll see you around.